Hello again, guys. We are back with measuring segments 7.3. So this will hopefully be a fairly brief video, but obviously we can measure segments. Like, you can take a ruler and you can measure it, but what about when we don't have a ruler, or when we have to compute it, when the points are already on a number line? So here is our general distance formula, that distance is always positive. So we use the absolute value here. Hopefully you can see these absolute value bars. We use the absolute value to determine the distance. So the distance from A to B, or B to A, is the absolute value of A minus B, or the absolute value of B minus A. It's just the difference between them, and then you have to make it positive because distance is always positive. So as we come over here, it says, what are UV and SV on the number line? So on the first one, I'll do A minus B. On the next one, I'll probably do B minus A. So UV. So let's call this A, and let's call this B. So to figure out UV, I would take the absolute value of A minus B. So actually, this one I'll do the easy way. 14 minus 10. You should be able to see that that would be 4. And when we make it positive, well, it's still positive. So then SV, this one, I will start with my lower value, negative 4 minus 14, which might seem like it's pretty ridiculous. But that gives me a negative 18, and the absolute value of that is a positive 18. So you see that the distance from S to V is a positive 18, which we know because from S to 0, that's 4. And then from 0 to V is another 14. So when you add them together, you get a total of 18. So go ahead and try on 1 and 2 to find the length of each of those segments on your own. And so pause the video for a second, do those, come back for your answers. BD, I'm going to go ahead and just set up absolute value of negative 6, and D is 3, so minus 3. This comes out to be absolute value of negative 9, which gives us the value of 9 for the length. CE is from 1 to 7. We could pretty easily see that that's a distance of 6, because it would be the absolute value of 7 minus 1, or 1 minus 7. Either way, you get the same thing. Distance between those is 6. So if we have 3 points that are all collinear, we can set up kind of some mathematical equations with them. As we see up here, AB and BC are on the same line, and since they're collinear, we can connect AB and BC to just call it AC. So we know that AC is the sum of AB and BC. So we can use this knowledge to help us solve problems just like this one. So we see that JL is 120, and they want us to figure out what are the lengths of JK and KL. So the first thing that I do, since this is telling me the length of the entire line, let's go ahead and add together the segments that I have to get the length of the entire line. So I'm going to add JK plus KL to get my JL. Sorry, I think I called that I at one point. So JK is 4x plus 6. KL is 7x plus 15. Remember that we can only combine like terms, and this will add up to be 120. So my like terms, if I have 4x, variable term can only add to a variable term, and if I have 6, a constant can only add to a constant. So my x's, I get 11x, and 6 and 15 gives me 21. And that's all equal to 120. Now this is when the fun starts. This is when we turn this into an equation problem, solve for the variable, and then we'll just plug back in to get the lengths. So the first thing we always do when solving an equation is get rid of the constant value first. So to get rid of that constant value, I'm going to take my constant on the right, or on the variable side, sorry, is 21. So I'm going to take that 21 away from both sides. I get 11x is equal to 99. And then because 11 is connected with my variable through multiplication, we're going to use inverse operations and use division to get rid of that. So we divide by 11, divide by 11. I see that x is going to be equal to 9. Now we're not done. We found the variable value, but with that, we need to go find the length of each of those respective lines. So we're going to take the fact that x is equal to 9 and bring it back up to our top and plug in. So JK was 4 times x, but now it's going to be 4 times 9 plus 6. 4 times 9 is 36, plus 6 is 42. KL was 7x, but now it'll be 7 times 9 plus 15. I'll go ahead and show my work on this. 7 times 9 is 63, plus a 15 gives me a 78. So that is how we would find the length for both of those. If I add up 42 and 78, I do in fact get 120. So we know that our work is correct. So if RS is 15, so I'm going to go ahead and label RS is 15, ST is 9, then what is RT? Well, we see that RT is just the sum of RS and ST, so we can just add those together and get that my answer here is 24. Now, if ST is 15, so we got to wipe this away. Now, if ST is 15, and RT, notice it's the whole length, so I actually like to notate that a little separately, is 40. Well, again, we know that that entire length was the sum, so what we have here is a difference problem now. RS, right here, is going to be the difference between 40 and 15, so we know that RS is actually RT minus ST, so that's going to be 40 minus 15, which is going to give us a value, sorry, different problem here, so we'll wipe that away, of 25. So of course, this line was different for problem 3 versus problem 4, but always realize that it's just a sum or a difference problem when we're talking about segments. Sorry about the quality of the print here. So when numerical expressions have the same values, you say that they are equal. Similarly, two segments that have the same length, we then call congruent. So congruent, different than equal, really just means they are exactly the same. So it's just a fancy way. So this deals more in geometry when we see that they are similar and equal, not just similar. So just the squiggly line above the equals, that would mean similar. With the equals below it, it means congruent. So AB is congruent to CD. Therefore, I can notate that with these little tick marks. Some people call them hash marks. That tells me that they are congruent to each other. So we see, is AB congruent to DE? So AB, we first need to figure out, well, what is AB? Well, it looks like B is at 3. DE, so we can see DE pretty easily from 10 to 14 is 4. And AB, if it goes from -2 to +3, we can go ahead and show the work for this. That'll be the absolute value of 3 minus a -2, which is really addition. So that gives me 5. So since DE is 4 and AB is 5, these are not congruent to each other. So no, they are not congruent. To find AC, suppose you subtract -2 from 5. Do you get the same result as subtracting 5 from -2 and y? Now, I already talked about this earlier. We don't even need to see the line to do this. What they're asking is to find AC. And if you want to see the line, I guess I'll move a couple things. So to find AC, as long as we're using absolute value, we should get the same answer. So you subtract -2 from 5. Sorry, the first thing I need to do is 5, subtract the -2 from it, versus if I do the 5 from the -2. So minus a negative we know becomes plus a positive, so this actually becomes 5 plus 2, which becomes 7. -2 minus 5 becomes -7, but remember that the absolute value makes it positive, and we get 7 for both of these results. So yes, it is exactly the same. This is why absolute value is so convenient. It makes my subtraction commutative. Actually, inside the absolute value, as long as there's just b minus a or a minus b, order doesn't matter. That absolute value is going to fix it for us and is going to make it all come out positive. 5 and 6 here. So we've got Ln and MQ. We need to determine if these segments are congruent. So let's determine where they are first. So -5, 6, 7, this is at -8. and m is at -3, n is at +3, p is at +6, and q is at +12. So ln, to find that length, I'm going to actually start with n because it's easier to subtract away the negative because it becomes addition. So this really becomes 3 plus 8, which gives me 11. And mq, absolute value. Again, I'm going to start with my positive because it makes life easier. 12 minus -3. That becomes addition. That comes out to be 15. So are they congruent? No, to be congruent, they would have to be exactly the same. MP. So MP. One positive, one negative. Start with the positive 6 minus a -3. That becomes addition and becomes 9. And then we have Q. And that's positive numbers. So that is easier to start with the bigger one. 12 minus 3. And that comes out 9. So yes, these two are congruent because they come out to be the exact same length. Bisectors are great. So the midpoint of a segment is the point that divides the segment into two congruent segments. So a point line ray or other segments that intersect is called midpoint, and it's said to bisect the segment. The segment meaning two. We're cutting into two. That point line ray or segment is also called the segment bisector. So here L is my segment bisector for the line AC. So here we see that U is the midpoint of TV. If there was a line through that line, that line would be bisector. So what this really tells me is that TU is equal to V. So we can use this information to set up an equation, which is going to start with variables on both sides, and we can manipulate to get the variables together and then solve. So what we set up is 8x plus 11 equals 12x minus 1. We know that because that's the bisector, that equals that. So I like to put my variables on whatever side starts with the larger variable. There's no right or wrong way to do this. There's a lot of right ways to get to Florida. So if you solve your equation differently than I do, totally fine as long as you get the same answer and you solve it correctly. First step I'm going to do is subtract 8x from both sides. I do that to group my variables together because now 8x minus 8x on the left side, that disappears, and I end up with just 11 over here. 12x minus 8x, I get 4x, and I still have the minus 1. Just like I grouped the variable terms together, I want to group my constant values together. So to get rid of a minus 1, we add 1. And that then gives me 12 being equal to 4x. The last thing I have to do is solve for x by isolating it. To isolate the x value, we use inverse operations, which here will lead me to divide. 12 divided by 4 comes out to give me a value of 3. But again, we're not done yet because it wants to know what the lengths of TU and UV are. But the convenient thing here is once I find one of them, I've really found both of them. But if we want to be precise, we want to find both of them and make sure that we did this correctly and we get the same answer for both. So for TU, let's plug in a 3 where we see an x. So 8 times 3 plus 11, this becomes 24 plus 11, which becomes 35. And I will just change color for this. We have 12. What we're asking is this equal? If we did our job right, it should be equal. So 12 times the 3 minus 1, that's 36 minus 1, and becomes 35. These are equal, so this checks out. And we know that we did our job correctly. This should be... we got one more problem. So hopefully this all made sense to you. Try number 7 on your own if you have yet to do it. Pause the video, try it out on your own, and come back for the answer. So it says A is the midpoint of XY. So we know A chops that segment into 2 equal halves. I sometimes like to notate that this segment equals this segment just to get used to that process. So again, we're going to set up an equation relating those 2 segments equal to each other. So we have 3x equal to 5x minus 6. And again, group your variables.
Because I have only a variable on the left-hand side, I'm going to go ahead and take all my variables to the left-hand side just to make this problem a little bit shorter. Now, the one weird thing it's going to do is it is going to make my variable value negative. Sorry, not minus 3x. This is what happens when you talk and write at the same time. I want to get rid of the 5x from the right-hand side, so I subtract 5x. That makes my left-hand side become a negative 2x, but that's equal to a negative 6. So as you can see, my negatives are going to cancel when I do that division. And x becomes a positive 3. We plug that in up here. Well, 3 times 3 times 3, this would be 9. 5 times 3 would be 15 minus 6 also equals 9. So they are both equal to 9. XA equals 9. Then it says find AY and XY. Well, we already found AY when we were finding XY. Or sorry, when we were finding XA. So now XY is just the sum of the two segments. So we know that would be 18. That is everything I have for our lesson today. So please let me know if you have any questions, comments, or concerns. Aside from that, I will see you guys later. Have a wonderful day.